Today we will be creating a smart study buddy with OpenAI and LangChain. What the application will do is it will take study material from a PDF and generate questions and answers based on that study material. You will learn about PDF loaders, vector databases, summarization chains, word embeddings, and much more. But before we dive into the code, let me quickly explain to you what is happening under the hood of the application. So what is happening under the hood of the application? Well, we'll be using your PDF with all your study material, and we'll be using a LangChain document loader to extract the text from the PDF. Once we have that extracted text, we will use a text splitter to create smaller documents, and we'll do that for the question generation and for the question answering. Let's first go to the question generation part. So once we splitted the text into smaller documents, we'll feed them to a summarization chain. We'll customize this one because usually what it does is summarize a document, but we want it to generate practice questions based on the study material. So we'll use a bit of custom prompting there. Once we have those generated questions, we will use a retrieval question answer chain to generate answers. So a retrieval question answer chain uses three components. One, a question. Two, a large language model. And the third part is a vector database. And a vector database is just a storage of vectors. And in our case, it are word embeddings, which are just numerical representations of text. So how do we get to the vector database? Well, we'll go back to the beginning. We've loaded the PDF, we've extracted the text, we've split it into smaller documents, and then we'll be using a vector database called Chroma to store all the vectors. Once the vector database is ready, we've got everything for the retrieval chain. So what happens there? It takes a question and it will use something called semantic similarity search to find the most relevant documents to that question. So it looks through all the documents and see which pieces of text are most relevant, and then uses those specific chunks plus the initial question inside of a large language model to generate an answer. So once we've got the answer, we're done. So we have the generated question, we have the answer, and we will show them both on the screen and save them to a file. So now I hope you have a bit of a better understanding of what is going to happen inside of the application. And now we're going to dive into the code. We're going to go through three simple steps. We're going to load and extract the data from the PDF. We're going to generate the questions. And finally, we'll generate the answers to those questions. In order for us to get the data from the PDF, we'll use a LangChain document loader called the PyPDF loader. What this does is just extracts the data from the PDF and adds some additional metadata, like page numbers. So we've imported the PyPDF loader, and we'll set our file path, and then we'll use the PyPDF loader to initialize the loader, and use the loader.load function to actually load the data. So now we need to split the text, which we extracted from the PDF, for a large language model to work with it effectively and efficiently. A large language model has a maximum token capacity it can work with, and a token is just a piece of a word. Usually it's around 3 characters, so a nice rule of thumb is 100 tokens equals approximately 75 words. Before we can split the text, we need to do one pre-processing step, which is to combine all the extracted text into a single variable, and we'll do that with a simple for loop in Python. And now it's time to do the actual splitting of the text. I'll be using the token text splitter, but you can use any one you like. I like this one because you can directly tell the model how large a chunk can maximum be in token count instead of character count. To initialize the text splitter, you need 3 arguments. The large language model you're going to use, the chunk size, and the chunk overlap. In our case, we're going to use a chunk size of 10,000 because we want the amount of calls we're going to make to the API to be as low as possible. Once we've initialized the text splitter, we can use the function .splitText in order for the text splitter to actually split the text. And you'll see we have 2 documents right now. You need to do one more step, which is transform the splitted text into documents again, because that's how LangChain works best. Do that with another simple for loop to just transform those documents. So now we'll split the text for the question answering part. In here we want the chunk size to be as small as possible, because remember we're going to use a retrieval question answer chain, which will query a vector database, and it will ask a question to the vector database, find the most relevant chunks, and feed those chunks into the large language model. So we want it to be smaller because of cost efficiency. So we'll set it up with a chunk size of 500, and you'll see that instead of 2 documents, we'll now have 26 documents. So we've splitted the text. Now it's time to generate the questions. And first we need to initialize our large language model. I'll be using the GPT 3.5 Turbo 16K model because it's cheap, it's quite fast, and it has a token limit of 16,000 tokens, so approximately 12,000 words. In order for us to use that model, we'll import chat OpenAI from LangChain, and we'll set our OpenAI API key. If you don't have one yet, there's a link in the description on how to get one. Now you can initialize the model, and you need to give it 3 arguments. So that's your API key, the name of the model you want to use, and the temperature you want the large language model to have. The temperature is just the creativity of a model. So when it's closer to 1, it gets to be more creative. When it's closer to 0, it gets to be more deterministic. In our case, we want the model to be quite creative, but also stick to the study material. So I use a temperature of 0.4. But please play around with this and see what works best for you. So you'll initialize the model in the following way. And now we're ready to set up our summarization chain. A summarization chain is just another handy feature in LangChain, which lets you summarize full documents with just a single line of code. But in our case, we don't want it to summarize the documents, we want it to generate questions. And in order for it to do so, we need custom prompting. So a prompt is just an instruction to a large language model. When you go to ChatGPT and you tell it to generate a workout schedule, that's your prompt. It's a very lousy prompt because there's been a lot of research on how to write a good prompt, but we won't get into that today. I'll just show you the prompt we're going to use. Because we are going to use a refined summarization chain, we need 2 prompts. The first one to generate questions for the initial chunk, and the second prompt is for all the subsequent chunks. So let's take a look at the first one. You are an expert in creating practice questions based on study material. Your goal is to prepare a student for their exam. You do this by asking questions about the text below. So this part will be replaced by the initial chunk that's being fed to the large language model. And then we tell it to create the questions for the exam. For the second prompt, which is the refining part of the summarization chain, we'll change one thing. We'll add the line, we have received some practice questions to a certain extent, and this part will be replaced by the generated questions from the first prompt. And then we'll feed it with the second chunk, and then it will refine the questions it's already generated with the additional content. This will make more sense once we really run the chain. So we've got a prompt set up. Now it's time to initialize the summarization chain. You need 4 things for this, which is the initialized large language model, the question prompt, the refined prompt, and the chain type. In our case, the chain type is refine. And I've also added a 5th variable, which is verbose. You'll see what that means in a bit, but it tells the large language model that it has to show its thought process on the screen. So we'll just import the load summarize chain from the LangChain library, and then we can initialize the question gen chain. So as a large language model, we'll use the one we've initialized, chain type refine, verbose is set to true, and the question prompt and refine prompt are set to the prompts we just created. So now it's time to actually generate the questions. So this is where the magic happens. It's just a single line of code. We just run the created chain on the documents we've split earlier. And now you'll see what verbose means as well. This will run the prompt. So here you can see the prompt we created with the first chunk, which is quite large because we used a chunk size of 10,000. And then we need to scroll all the way down. And this is where the second prompt comes in. So here you can see that these are the generated questions. And it has some more information from the second chunk. So the questions are finished. We can show them on the screen real quick. We've got 10 questions, and now we will generate the answer to those questions with a retrieval question answer chain. The retrieval question answer chain needs three things: a question, a large language model, and a retriever. In our case, the retriever will be a vector database, which is just a storage of word embeddings. And these word embeddings are just numerical representations of the semantic meaning of a certain piece of text. So let's set up this vector database. We'll be using the OpenAI embeddings and a Chroma vector database to create the database. Just import OpenAI embeddings, set your OpenAI API key, and import Chroma. All made very easily through LangChain. And then we can set up our Chroma vector database with the .fromDocuments function. And it uses the documents we've splitted earlier and their corresponding word embeddings. So we've got our vector database. Now we're going to initialize another large language model, which is quite similar to the one we did first, but now the temperature is a bit lower because we wanted to stick more to the study material. So we'll just change the temperature to 0.1. And now we import the retrieval question answer chain from LangChain. So we've got the large language model, we've got the vector database, and now we need the question. So we've got the 10 questions which are stored inside a single string, and they need to be split up into a list of separate questions. We'll just use a simple Python function, the .split function. And as a delimiter, we will use the new line, which just means an enter. Now we have everything we need to initialize the retrieval question answer chain, which we'll set up with the large language model we just initialized, another chain type, don't worry about that for now, and a retriever. And the retriever is the vector store we just created, .sRetriever, and we use an additional argument k equals 2, which tells the model that it needs to find the two most relevant chunks to the question. So now everything is set up. We can generate answers for our generated questions, all based on the study material from your PDF. We just run a simple Python for loop. We'll show the question on the screen, and then it will generate the answer to that question. So let's hope this works. At least it shows the question at the moment. And then in the back end, it's generating the question now, or generating the answer, which should pop up on the screen. That's perfect. And now it's going to the second question, and it will go through all 10 questions. We'll save it to a file later on for you to use. So that's it. Now you're done. You've created your first LangChain project. The next step will be to implement this project into a front end called Streamlit. I will do this in the next video, so keep an eye out for that. Thank you all for watching. See you next time, and leave a comment down below what you would like to see for a next project. Thank you.